Okay, so in the last video, we worked on basic proofs in TFL, applying basic rules like and elimination, or introduction, or elimination, arrow elimination, things like that. We spent a little bit of time getting comfortable with making basic steps in proofs. And now today, in this video, we're going to work on conditional proofs. So these are the ones that involve making an assumption, or some of the ones that involve making an assumption. And usually this is where things can get a little bit tricky if you're learning proofs in TFL for the first time. So in the last video, I gave you a bunch of rules, all the rules that we use in TFL. And today we're going to look at a couple of those rules. So the first is a conditional proof. It's if we're trying to prove the sentence A implies B. If we're trying to prove A implies B. And also we're going to look at a biconditional proof, which is basically A biconditional B, or you can understand this as A and B imply each other. So the arrow runs both ways in these biconditional proofs. So how you prove a conditional proof, or how you prove a conditional statement, is you assume whatever is on the left, and then try to show that whatever is on the right follows from that in the basic rules. So how this looks is you start a subproof. Remember, this vertical line means that you're making an assumption, and you assume what's on the left. Okay, you say, hey, suppose A. You start an assumption saying, suppose A is true. You do a couple steps, you use your rules that we used last time, and hopefully you get B somewhere down here in this subproof. Once you're finished with that, you can exit the subproof and write A implies B by this rule, arrow introduction. Now for a biconditional proof, you do the exact same thing, but you have to do it both ways around, or you have to do it twice. So in a biconditional proof, you're going to start an assumption where you assume A, show that B follows from that, and then you close off that subproof. So you say, okay, I proved that A implies B. That's what this is, right? You assume A, show that B follows. It's just this thing over here. That proves A implies B, but now you've got to prove that B implies A as well. And how you do that is exactly the same way you do this, except you exchange B and A. So you start another subproof, assuming B, or whatever's on the right side of the arrow, right? Use your rules, do a couple steps, you're going to show that A follows. Once you've done all of that, that's a proof that A and B imply each other, and this one is called biconditional introduction. And then this subproof, of course, is a proof that B implies A. So really you kind of look at this as two separate proofs. One that A implies B, and the other that B implies A. This shows that they imply each other, okay? So we're going to look at an example of this where you can try it out for yourself. Okay, and that example is going to be this problem right here. We're going to have as a premise P or Q. And then as another premise, Q or R. And then we're going to show that negation Q implies P and R, okay? So now's your chance to pause the video, try it out. If this is your first time doing this, I'll give you a little bit of guidance. This is a conditional statement, right? It has an arrow as its main connective, which means you're going to assume this guy. And then once you assume that, you're going to do a couple steps, try to show that this guy follows. That's going to allow you to exit your subproof and write that negation Q implies P and R. So go ahead and pause the video, try it out, look at your arrow introduction rule, and see if you can apply it to this case. Okay, so first thing I'm going to do is I'm going to start an assumption right here. That's what this vertical line is, right? An assumption. And I'm going to assume what's on the left. So in this case, negation Q. And I'm going to put over here, want P and R. So here's what we need to happen, okay? Inside this subproof, we need to do a couple steps, and somewhere down here, we want to get this sentence P and R written down. Once we're done with that, we can exit this subproof and write negation Q implies P and R. This should make some sense how this is structured, because you say, hey, let's say negation Q is true. If the sentence P and R logically has to follow from that, that's as good as saying that not Q implies P and R. This is more or less what it means, what implication means, is you assume one thing, and then the other thing must be true. Logically, it must be true. That's what implication means, this arrow right here, okay? So if you had a little trouble starting the proof, see if you can fill out these missing steps. See if you can use the sentence negation Q to get yourself to P and R. So go ahead and try that real quick. Okay, so here, once I'm assuming negation Q, look at lines 1 and 3. Okay, this is going to be an example of or elimination, our friend from the last video, right? If you know the sentence A or B, one of them is true, and you find out it's not A, that means it must be B, right? And lines 1 and 3 are an example of this. You know that P or Q has to be true, and this says, hey, we're assuming it's not Q. So that means it has to be P. And so we're going to use or elimination there, lines 1 and 3. And then, for the exact same reason, you know that R has to be true, right? Because this says Q or R is true. This one says it's not Q. So you can use the exact same rule to show that R must be true. So this is or elimination, but this time on lines 2 and 3, okay? Now we want that sentence P and R down in the proof, right? We've proven P and R separately, right? And our and introduction rule, I'll remind you of this from last video, our and introduction rule goes like this. If we have two separate sentences, we can stick them together with an and symbol, right? So we can do that with the sentences P and R right here. We have them separately, so we can stick them together with an and symbol like this, using and introduction, lines 4 and 5. And then great, we got that sentence that we wanted there, right? When we assumed Q. So we assumed negation Q. We assumed negation Q, and we found that the sentence P and R logically must follow. So that allows us to exit our subproof and write negation Q implies P and R. And this is going to be arrow introduction. And you're going to cite that whole subproof, 3 through 6. 3 through 6, like this. Notice how I put a range of lines here. This is because I'm citing the entire subproof through here, right? This was my proof that not Q implies P and R, so you're going to cite the whole range of lines right there. And that's our result. We proved our result. Okay? So, an important thing to keep in mind is that anytime you're trying to prove a conditional statement, at least in our system, you're going to use this strategy, okay? So if you see over here, oh, I'm trying to prove a conditional statement, don't think about it too hard, just assume whatever's on the left, do a couple steps, show that whatever's on the right follows, and then you can write your result by arrow introduction, okay? It always goes this way. So let's try another one now. Let's try another one here. Next one is going to be this guy. We're going to have A, biconditional negation B, and then we're going to have C implies, what is it, B or D, and then we're going to try to prove that A implies that C implies D. Okay, now's your chance to pause the video, give this thing a shot, See if you can prove this conditional here that we're trying to prove. Now, if you're getting overwhelmed by the fact that there's two arrows in this, mainly the thing that you should do here is try not to overthink the fact that there's two arrows. Really what this statement is that you're trying to prove is just a conditional statement between two sentences, right? It's the idea that A implies this other sentence. So I don't have to worry too much about that other sentence. I just look at this as trying to show that A implies this guy, okay? And like I said a second ago, these always go the same way in our system, okay? So you're going to assume what's on the left, in this case A, right? You're going to put want C arrow D, because that's what's on the right, right? Now, what this means is that somewhere downstairs here in the subproof, we have to write down the sentence C arrow D. That's what's going to let us close out our subproof and write our result, right? So then you look at this and you say, okay, well, what can I find out just from the sentence A? Well, if you look at line 1 tells you that A and negation B imply each other, right? They imply each other. So I can use this to conclude not B. Okay, well, that's information you can get out of line 3, right? And this is going to be biconditional elimination from lines 1 and 3. If this is a little confusing, remind yourself of the rules that we went over the other day. If you have a biconditional statement like this, you find out that one of the sentences is true. Great, now you know that the other one is true too. This is biconditional elimination. So then we start to ask ourselves, how can we get this sentence C arrow D written down in our subproof? This is a conditional statement, right? C arrow D. So to prove it, I'm going to have to use a conditional proof for C arrow D, right? And we know how to do a conditional proof, but a lot of times this can be a little bit confusing. But really it works the exact same way every time. We want to prove the sentence C arrow D. Well, we know what we have to do for that. We have to go in here inside our subproof and assume C. So notice what's happened here is this is another assumption I'm starting within the subproof that's already running, right? So this is going to be C want D, because I'm trying to prove the sentence C arrow D now, right? Now that I'm working under this assumption, I can see that lines 2 and 5 tell me that this sentence must be true, right? C implies B or D, and now I'm assuming C, so the sentence B or D follows. And this is from lines 2 and 5, arrow elimination, right? Again, if you're not quite sure what's going on here, go ahead and look back at that note sheet, look at the arrow elimination rule, and see how lines 2 and 5 allow you to use that, okay? Now what can I do from here? Here's the thing, there's two assumptions running here, right? There's this assumption of A, and then inside that I made this assumption of C to try to prove C arrow D, right? So anywhere in here, I can use these assumptions from out here because everything in here is still running under this assumption of A, right? So I can go in here and use both of these facts from out here. And that's exactly what I'm going to do. So look at lines 4 and 6 now, and you'll see that this is a case of OR elimination, right? I can use OR elimination on lines 4 and 6. This tells me one of B or D has to be true, right? And line 4 tells me, hey, we're already working under the assumption that B is false, right? We're working under the assumption of not B. So this tells me D has to be true by OR elimination on lines 4 and 6. Okay, so we wanted to show that when you assume when you assume C, the sentence D ends up following. And we did show that, right? So this allows us to exit this subproof right here, this inner subproof, and write C arrow D. This will be arrow introduction, lines 5 through 7, like this. And so now we're back in this first subproof, right? This one did its job. This one was to prove C arrow D, and it did its job. We did it, we proved C arrow D. So if we remember what we wanted here, we wanted to show that when you make this assumption A, C arrow D has to follow, right? And we did. That's what line 8 says. We made this assumption A, we did some steps here, C arrow D followed. So now we can pop out of this subproof and write our result. A implies C arrow D. By arrow introduction, this entire subproof, 3 through 8. Okay, so a couple notes on this thing. This entire thing is just a normal conditional proof, right? I assumed what's on the left, and I showed what's on the right. But to do that, I had to run another conditional proof inside this subproof, right? So that's the only thing that's different about this, is I had to prove a conditional statement inside this conditional proof that I'm already doing, right? This doesn't mean anything works differently about this proof. It's just that I had to do the process again inside this subproof that was already running. Okay, now one more note before we move on. This subproof right here is all done under the assumption of C, right? I started this thing assuming C, and so here's what I can't do. I can't take a sentence D and say that it's true outside this subproof right here. I can't do that because once I finish it, I've already discharged the assumption, right? I've already said, okay, this whole hypothetical situation of C being true is done with. It did its job because I proved that C implied D. I can't go pulling facts from inside this subproof anymore. But you'll notice that in this larger subproof from 3 to 8, I can use facts from inside this big subproof inside here, inside the smaller subproof, right? I did that with not B. I used the sentence not B to work on this guy, right? When I got the sentence D. But that's okay because even this thing, this vertical line is still running. This was all done under the assumption of A. So I can still use in here any information from this assumption of A. This can be a tricky thing sometimes when you're learning it, is you can use any assumptions from out here in here, inside this inner subproof, but not the other way around. You can't use stuff from inside here out here because your vertical line is no longer running. You've discharged that assumption of C whenever you're outside this inner subproof here. Okay. Last one we're going to do to work on this is we're going to do this one right here. We're going to have A and not B imply each other, biconditional. And then we're going to have not B and what? C imply each other, it's another biconditional. And we're going to try to prove that A and not B and C imply each other. So this is a biconditional statement, right? This is a biconditional statement now. So look at your directions for doing a biconditional proof. Look at those directions for a second and take a shot at this problem. See if you can do, see if you can prove your result here. Here's a little hint just to get you started if you're not working on it already. I need to assume A and then show that this follows, right? So that's going to be its own conditional proof. Once I'm done with that, I'm going to close that one off, and then I'm going to start a new one where I assume this and then show this. Once I've done both of those subproofs, you can finish things up and you can write your result. These two sentences imply each other. Okay, so pause the video, go ahead and try that out. Okay, let's start this thing off. So first, I'm going to assume this and try to show this. Okay, so I'm going to assume A, want not B and C. This is just a normal conditional proof so far. And I'm going to run through these a little bit quicker, okay? So 1 and 3 tells me that not B must be true, right? Because A implies not B, and I'm assuming A now. So now I get to conclude not B, and that is going to be biconditional elimination on 1 and 3. If you're not sure about this step, go look at your biconditional elimination rule and see that lines 1 and 3 are a case of that. They're a case where you can apply that. Now that I have not B, I can do the same thing to get the sentence C. Look at this pair right here. Not B implies C, and here I have not B, so I get C by the exact same rule. And this is going to be 2 and 4 now. Now I want this sentence not B and C. I have them separately right here. So all I have to do is stick them together with an or symbol. Excuse me, an and symbol. So that's and introduction, 4 and 5. Again, if you're not sure about this, review your and introduction rule right there. And that is my result right there. So then I close this subproof off, okay? And this thing you can understand as a proof that A implies not B and C. But notice we've only done half the job, right? We've proven that A implies not B and C, but we got to show the other way around too. So let's do that. We're going to start a new subproof where we swap things. We assume not B and C, and we put want A. Now, if you're learning this for the first time, you might say, well, hold on a minute, Eric. I can get to A simply by reiterating line 3. I have A up in line 3, so I can just reiterate it down there. And my answer for you is that's a big, big no-no, okay? You can't do that. Why not? Because this assumption has already been discharged, right? I've assumed A and I've showed that not B and C follows. But now I have to do the other thing. I have to go the other way around, right? I have to show not B and C logically has to lead to A. And I can't do that off an assumption of A, right? So once this subproof is done, it's done. You cannot pull from this subproof anymore to try to get your results, okay? This is very important with subproofs and conditional proofs. What I can do is take out the sentence not B by and elimination on 7. Again, this tells me both not B and C are true. That means that not B is true if you look at your and elimination rule from last video. And then not B and A imply each other. That's a premise, right? So because I have not B and not B implies A, I can go just write A down here by biconditional elimination on 1 and 8, right? Remember that biconditional implication goes both ways. If I get this guy, I can conclude this guy. But if I get this guy, I can conclude that guy as well, right? So it goes both ways. Biconditionals are very nice that way. And here we go. I did my job of showing that A follows from this assumption. So I get to come down here and write my result. A biconditional, not B and C. And this is going to be biconditional introduction. And then I'm going to cite both subproofs. So 3 through 6 and 7 through 9. Like this. Okay? So again, this other subproof down here, you can understand as a proof of this. Not B and C implies A. You take these two proofs together, and that shows you that the implication runs both ways, right? Not only does A imply this, but this implies A as well. That's pretty much what it means for something to be biconditional, or for implication to go both ways like that, okay? Great, so again, any biconditional proof is gonna look like this. You're gonna do one subproof over here, you're gonna swap these sentences in the next subproof, and then once you do that, you can write your result by biconditional introduction, okay? I hope you found this helpful. Next time, we're gonna start doing proofs by contradiction, or we're gonna start using the negation rules if you watched the last video, okay? Those things are gonna be pretty heavy on the subproofs. We're gonna get to practice using all of our skills in those videos. So before you move on, make sure you understand these problems, okay? How to do a conditional proof, and make sure you understand those annoying rules about assumptions that I went over, like, when this assumption is discharged, you can't pull sentences from it anymore, things like that. That's all very important to understand before we move on. So I'll see you in the next video where we'll work on proof by contradiction.